Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Najib, Geometry AA200513. Today I will talk about introduction for Digit project, introduction for flip-flop and application, then explanation of counter, FSM and register, and the last part, example of application for that things. Okay, first of all, for introduction, flip-flop and application. Flip-flop is an electronic circuit with two stable states that can be used to store binary data. The stored data can be changed by applying various inputs. Flip-flop and latch are fundamental building blocks of a digital electronic system used in computer, communication, and many other types of systems. Both are used as data storage elements. It is the basic storage element in sequential logic. For example, SR flip-flop, JK flip-flop, D flip-flop. For the application of flip-flop, are counter, frequency divider, shift register, and storage register. So we move to the FSM, which is finite state machine. FSM is synchronous counter design using excitation table method state machine. That is, a state machine can be viewed as a synchronous counter with irregular sequence. There are two sorts of state machine. For the first one is Moore machine, then second Mealy machine. Okay, I move to the counter. Counter is a F2 type, which are synchronous counter and synchronous counter. The difference for the both of them is in synchronous counter, or all flip-flop are triggered by same clock simultaneously. In asynchronous counter, different flip-flop are triggered by different clock, not simultaneously. Synchronous counter is also called parallel counter. Asynchronous counter is also called serial counter. So the register, a register may be a digital circuit with two basic functions. The function is for data storage device, data movement, shiftability, and transferring data. There are four types, which are PIPO register, CISO register, SIPO register, and PIPO register. For the application for finite machine, they are used in for vending machine, subway, interest, turnstile, a heating system, a self-driving car system, that most we can see nowadays is an elevator. For the register application, used in electronic device, like temporary data storage, data transfer, data manipulation. Then for the lastly, counter application, for example, washing machine, where we set the time. This counter are used. Then in the application of digital clock, counter are used. Okay, that's all from me for the introduction, flip-flop, counter, register, and FSM, which is finite state machine. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Aziz bin Muhammad. My number matric is AA200597. Okay, today I will present about our project, our Digit Electronic project. Okay, I do the Act 1. Okay, first of all, I will show my state diagram. Okay, this is my state diagram. The state diagram is 1 to 6, 3 to 6, 6 to 5, 5 to 0, 7 to 0, 0 to 2, 2 to 4, and 4 to 6. Okay. Next is next table. Okay, next table is have two column here. That is present state and next state. Okay. Present state is QC, QB, QA. We start with 0, 1, 2, 3, 4, 5, 6, 7. Okay, next state. We make it based on this state diagram. As example, from 0, 0, 0 from 0 to 2, 0, 1, 0. That's how I do it. Okay. Next is excitation table. Okay, excitation table. Okay, these two column I copy from the next table. Okay. The three column is flip-flop C, flip-flop B, flip-flop E. Okay. First of all, we start with flip-flop C. Okay. Flip-flop C has two input. That is J and K. Okay. To make it, we took from QC from present state and next state from QC. Okay. How we get 0x, 1x, x0 and x1. Okay. To make it, okay, we look here and here. From 0 to 0, so it's 0x. From 0 to 1, 1x, and 1, 1, x0, and 1 to 0 is x1. Okay, that's how I do it. So I took it and I put it here, and then I continue with input JB and KB based on QB and QB next state. For flip-flop A, also I make like that. Okay, after I finish my excitation table, I do Karnaugh map. Karnaugh map, first of all, is flip-flop C. Okay, there is two input, J input and K input. So I make table and do it. So I circle the one input, the one output. Okay, and I get for J input is QB plus QA and K is QA. Okay, for flip-flop B, I get J input is QC bar plus QA bar and K input is QA bar plus QC. For flip-flop A is J input is QC multiplied by QB and K is 1. Okay, next is my circuit. Okay, so this is my circuit. I use 1 AND gate and 3 OR gate. Okay, this is flip-flop A, flip-flop B and flip-flop C. And I take the output from Q each JK flip-flop. Okay, after I finish my circuit, then I continue it and make it at Tinkercad. So this is my circuit on Tinkercad. So this is JK flip-flop and this is also JK flip-flop and this is AND gate and this is OR gate. Okay, so this is my link for Tinkercad circuit. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, nama saya Muhammad Firdaus bin Muhammad Sulki, Geometrik AA 2051. Okay, hari ini saya akan membentangkan berkaitan projek yang projek digit pada part B. Okay, soalan B, task 2. Okay, di sini kita boleh tengok adalah dia punya logisim circuit lah. Okay, logisim circuit ni saya buat menggunakan logisim apps lah. So saya ambil daripada logisim apps dan dia punya litar ni saya ambil contoh daripada soalan. So soalan telah menyediakan dia punya litar. So saya just ambil dan buat pada logisim circuit. So saya buat macam ni lah, sama macam bentuk soalan. Okay, lepas tu dia telah menyediakan table. So daripada soalan tu telah menyediakan table dan table yang telah disediakan tidak mempunyai value output. So di sini task dia adalah untuk mencari value output. So dengan menggunakan circuit di sini, simulation ni dan masukkan value input, so dia akan mengeluarkan value output yang telah saya buat dah. So dalam soalan value output ni kosong. So, I mean dia memang tak ada value lah. So semua ni kosong. So di sini saya telah masukkan value. So value ni saya ambil daripada simulation ni lah. So dengan saya masukkan input 1111, so masukkan dekat A, B, C, D dia punya input ni. So output dia akan keluarkan value lah. So di sini kita boleh tengok dia telah saya telah masukkan value yang ada dekat sini. So dengan saya pun masukkan semua input dekat sini. So saya telah keluarkan value output. So saya rasa itu saja daripada pembentangan saya kali ini. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq Hakimi bin Muhammad Baharudin. Okay, today I will be present about the discussion. Okay, about discussion, our discussion we make a minute meeting, and a minute meeting we do about 4 times. Okay, firstly, first minute of meeting we do is date at 21 June 2021, and the time is 11:50 AM until 12:30 PM, and the place is WhatsApp online. Okay, for the attendance, we all attend, and for the activities we do ice breaking, divided the task as if member have any problem with their task to do it. Okay, this for example, we do this example every day we do for the minute meeting for the first time. Okay, the second time we do at the date is 23 June 2021, and the time is 8:55 AM until 9:30 AM. Okay, for the attendance we all attend, and for the activity we ask the member if have problem with the task. Okay, and this the evidence for the second hour minute meeting. And thirdly, for the minute of meeting, we do at date is 25 June 2021, and the time is 8:30 PM until 9 PM, and the place is WhatsApp online, and for the attender is all the intent, and for the activity, some member have marked right for their complete assignment, and ask the member if have problem with the task. And this for the evidence for the third minute of our meeting. Okay, and lastly, our meeting is we do at the 26 June 2021, and the time is 12:30 PM until 1 PM, and the place is WhatsApp online only. And for the attender is we all attend and activity. We do like check all the report after being compiled and discuss if any improvement need to be added. Okay. Then this our evidence, our Google Meet we do for the 4 minute of meeting. Okay. And then lastly for 5 minute meeting, we do for submit report lah at the date 7 July 2021, 9 PM and until 9:30 PM at the outer online. Okay, for the attender is all attend and the activity, we submit the report and the link video presentation. Okay, for the application of this report, okay, FSM counter and register have long been used in our environment. These components are usually used in some electronic device in daily life. All these components are used according to the use and function of each component. Okay, for the counter, in our kitchen appliance, we use a microwave. Therefore, we set the temperature to heat the food stored in. It internally, the counter calculates the rise and fall of temperature and time. If it reaches the set temperature, then it will ever continue heating and damage to the food. Like the calculation operation in a microwave oven, the counter in the washing machine calculate the time we set to operate. Thus, the operation of the device is controlled by the counter. And next for the FSM, also the vending machine reverts a packet of candy after getting 20 cents in the coin. This machine is a single coin slot that only accepts 10 cents and 20 cents only. The mechanical sensor points to the control whether 10 cents or 20 cents has to be inserted into the slot coin. The release of the controller causes a packet of candy to be released to the customer. And lastly, the register. The most common use of register is to store digital data. Data and address can also be stored. Digital memory chip, such as ROM chips and flash memory, are also made with register. Flash memory is used in enterprise data center server, storage and network technology, as well as in various user devices, including USB plug, are also known as memory stick, SD card, and mobile phone. Okay, and the reference we have about 1, 2, 3, 4, 5, 6, 7, 8, 9 reference of this report. Okay, that's all from me. Thank you.